The final question is on vectors and starts off fairly straightforwardly, but quickly becomes fairly treacherous indeed. So let's have a look at this. In the first instance, then, we are given the points A with these coordinates and B with these coordinates, and we are asked to find AB. So because we've got the coordinates here, in effect, this is the position vector OA, and this is the position vector OB. And remembering that, suppose this is the origin here, and this is point A, and here this is point B. If we wanted to find vector AB, that is the same as going the opposite direction here. So this would be AO, or indeed negative OA. And then we would have to go this way, which is just OB. So we would say that vector AB is going to be the position vector OB minus the position vector OA. So we can say OB here is going to be this, so negative 9, 9, negative 6, minus position vector OA, which is going to be 1, 5, negative 7. So the vector AB then is just going to be the difference, so minus 9 minus 1 is going to give us negative 10, 4, 1. So that is going to be the position vector AB. Similarly, in part B, we're told that C is a point such that vector AC is equal to 6, negative 4, 0. And we're asked to find the coordinates of C. So likewise, we can kind of interpret the information in an equation of a similar form to this, in the sense that we know that vector AC would be the same as vector OC minus vector OA. We're trying to find the point C, so in essence we want to find the position vector OC, so we can say that vector OC is going to equal vector AC plus vector OA. Vector AC we've got here, so that's going to be 6, negative 4, 0. Vector OA we can interpret from up here, that's going to be 1, 5, negative 7. So if we add that together, we are going to get 7, 1, and negative 7. So the coordinates of C are going to be 7, 1, negative 7. For the final part on this page, then, the line passes through B and the line L passes through B and is parallel to AC. Write down a vector equation for L. So we know then that if it passes through the point B, it's going to have to go through point B, so we can write R equals negative 9, 9, negative 6. And then if it's parallel to AC, we know that there is going to be some component in the same direction, or the opposite direction if it was negative, so that would be T, and 6, negative 4, 0, which we're saying is parallel because it's parallel to AC, so that's going to be our vector equation. For part D, we are told that the magnitude of AB is some constant k multiplied by the magnitude of AC, and we're asked to find k. Well, fortunately, we've already found AB from earlier on in the question, so we can find the magnitude of AB, which is going to be, here is vector AB, so the magnitude is going to be the square root of 10 squared plus 4 squared plus 1 squared, which is going to give us root 117. The magnitude of AC we can also find, because that, we've got AC up here, so the magnitude of that is going to be the square root of 6 squared plus 4 squared, which is going to give us root 52. So we know, therefore, that AB, which is root 117, is going to be k multiplied by the magnitude of AC, which we're saying is root 52. Therefore, K is going to equal root 117 over root 52, which is going to give you a value of plus or minus 1.5. So the final sting in the tail is with part E, which says the point D lies on the line L such that the magnitude of AB is the same as the magnitude of BD, and we're asked to find possible coordinates of D. So from this question so far, we've already got AB, we've got the vector equation of the line, we also know initially the coordinates of B, which gives us this information here. So we're told that the magnitude of AB is the magnitude of BD. The magnitude of AB we have already worked out in the previous question, and we are told that that is root 117, which therefore must also be the magnitude of vector BD. If we think about how this would look, imagine if we were working in 2 dimensions here. So we had some point here, which is the origin. We had 2 points here, B and D. So if we were trying to work out the magnitude of vector BD, which would be here, we could do that by doing a negative OB, so this would be OB, this would be negative OB, plus OD. So we would essentially look at this. So we look at the difference in the two x values, square it, and we'd look at the difference in the two y values, square it, and we would take the square root of that sum. That would give us the magnitude of BD. So in essence here then, this is our magnitude. We know that, 117. So we need to then have a look at the difference between the x, y, and z, or I, J, and K components here. So first of all then, the problem is we don't know, if we're looking at here OD minus OB, we don't actually know what the coordinates of point D are, but we can use the vector equation of the line. So the x, or the I component here, will be the top, so negative 9 plus 6t, so that's just going to be the top line of the vector equation. So that's going to be the I component for D. So from that we need to subtract the same component for point B, which is going to be up here, minus 9. So that's going to be the difference in the x, so we can square that. To that, then, we need to do the same thing with the j, or the y component. So again, we don't know what the y component is for point D, but we can use the vector equation, and if we do that, we get 9 minus 4t, and from that we need to subtract the y component for B up here, which is going to be 9. Again, square that, and then look at the k or z component, which is going to be negative 6 minus negative 6 squared. So that's setting up the equation. You should be able to see then here that this negative 9 is going to cancel out with this, what's going to turn out to be plus 9. This 9 is going to cancel out with this negative 9, and this negative 6 is going to cancel out with this, which is going to leave us with the square root of 36t squared plus 16t squared, which is going to give us the square root of 52t squared, or root 52 times t. So remembering that this whole equation we've said is equal to the magnitude, which is equal to 117. So we can just rearrange this to say that t equals root 117 over root 52, which is, you will notice, the solution to part D. So this value of t will end up being plus or minus 1.5. So given then that we've got a value of t being equal to plus or minus 1.5, there's going to be two different possible coordinates of D. The first one then, we are going to say that the point D could be negative 9 plus 6 times 1.5, and then 9, so looking at the middle line here, the j component, 9 minus 4 times 1.5, and then just minus 6. So that would give us the point 0, 3, negative 6. The second coordinates, it could be then as if t was negative 1.5. So again, using the vector equation of the line, it could be negative 9. So this time it's going to be minus 6 times 1.5. That's just 6 times negative 1.5. 9 minus 4 times negative 1.5. So that would be plus 4 times 1.5, and then again here, negative 6. And we can simplify that to negative 18, 15, and negative 6. So if you got to the end of this question, well done, because that was especially difficult.